Welcome to this video. Here I will be solving this 1969 BC calculus multiple choice. This was a very old exam, so some of the content might not be the same as what's expected in BC Calc as of now, whenever you're watching this. So I'll leave it up to you to double check which topics are covered, which are not. Like for example, in this test, it asks about epsilon delta definition for the limit. I'm not sure if that's covered anymore, but things like that, okay? So also I want to note that there's lots of problems that are the same as the AB exam given in 1969. So I won't be repeating those per se. I might touch a bit on the what you need to do, but I'll refer to the video I made for that exam for the worked out solutions, okay? So let's begin. And this is a 90-minute exam. I might split this up into multiple parts as usual, okay? And also, one more thing, I did work out the problems beforehand, so I'm going to do that format in which I just show my solutions and talk through it versus me working it out live on the video, okay? Or it'll depend what the problem is. I might redo it also, okay? Anyway, so let's begin. The first one, asymptotes of the graph of the parametric equation. X is 1 over t, y is t over t plus 1. What are the asymptotes? Okay, so I worked that out over here. I hope it's, okay, it is visible. I just used pencil. So I immediately thought, well, okay, so here's the problem. Let's eliminate the parameter. So let's make let's make y in terms of x, or x in terms of y, it doesn't matter. In this case, it looks like y in terms of x is easier. So instead of x equals 1 over t, what's t equal to? You just invert both sides. T is 1 over x, okay? And then since this is t in terms of x, you can plug in that definition into y. So y is equal to t over t plus 1, that's in terms of t. We found t is 1 over x, so we plug in 1 over x. 1 over x divided by 1 over x plus 1, okay? Let's simplify it a little bit, or clean it up. Let's multiply the top by x and the bottom by x, so this is the same thing as multiplying by 1, so that's legal. And then we get 1 over 1 plus x, okay? It's very clear that there's a vertical asymptote when x is equal to -1, okay? Horizontal asymptote, we can do the degree test. The degree of the top is less than the degree of the bottom. Degree of the top is 0, degree of the bottom is 1. So there's a horizontal asymptote at y is equal to 0. If you don't remember that rule, you can just take the limit as x goes to infinity. That's 0. To negative infinity, it's also 0. So that also works, okay? So we have horizontal asymptotes at -1, x is -1, and y is 0. So that's choice C, okay? This one I did on the AB exam. The key here was inflection point. You should find the second derivative, okay? So I won't go over that again. Okay. Mean value theorem guarantees the existence of a special point on the graph y is square root x between 0, 0 and 4, 2. What are the coordinates of this point? What does mean value theorem say? Well, it's, first of all, the function has to be differentiable. And this guy is differentiable, okay? At least even in 0, x is 0 to 4, it's for sure differentiable, okay? Mean value theorem says, did I write it over here? So actually, is number 2 done on the AB exam? It's not, okay, so let me actually do it, my bad. Okay, coordinates of the inflection point. So as I said, inflection point should signal second derivative, okay? So this is the first derivative. This is y. So let's find the first derivative. We need the product rule. So first d second plus second d first. That's the product rule. That's how I remember it. First d second derivative of arctan is 1 over 1 plus x squared, plus second d first derivative of x plus 1 is just 1. Okay? And this is the first derivative. We can find the second derivative. Okay? This guy, we would need quotient rule. Quotient was bottom d top minus top d bottom over bottom squared. So bottom is this guy. D top derivative of this guy is just 1 minus top d bottom derivative of this guy is just 2x over bottom squared, okay? This one, the derivative is 1 over 1 plus x squared. Once again, okay? So let's do some cleaning up. Over here, what did I do? I probably distributed this 2x to both terms. Okay, that's that. Here, I multiplied both the top and bottom by 1 plus x squared because I want to get a common denominator. Okay, and then over here, what did I do? This is 1 plus x squared. This is another 1 plus x squared. So that's 2 plus 2x squared. That's how I combine those. And this I left the same still. Okay, and then I combine the fractions. Okay, so if we simplify this, we would get 2 minus 2x divided by 1 plus x squared, quantity squared. We set this equal to 0. Okay, the critical point is x is 1. So let's do the second derivative test. We plug in some number less than 1. For example, 0. If we plug it into the top, we would get a positive number. If we plug in a huge positive number, the top would be negative. Okay, so we see that the second derivative changes sign, so we know that there's a point of inflection at x is equal to 1. Okay, what's the y coordinate of that point? You just plug it into here. So y of 1 is 1 plus 1 times arctan 1, which is 2 times pi over 4. Okay, so it'll be 2 times pi over 4 is pi over 2, so 2 is e. So back to 3, this one, let's talk about mean value theorem. So what does mean value theorem say? Well, once again, this has to be differentiable in the interval. So it is differentiable in this interval, okay? So what does it say? Well, let me even just sketch it out here, okay? That's 0, 0, and 1, 4, comma 2. The square root looks like this, correct? I'll keep going like that, okay? Mean value theorem says there's some point, so if we draw a secant line, okay, this has some slope. Let's call this slope m, okay? The mean value theorem says at some point between these 2 points, okay, there is some point such that the derivative has the same slope. We'll have, there's some point where the slope of that tangent line at that point is the same as the slope between the 2 points. That's what the mean value theorem says. Hopefully that sounds familiar, okay? So let's go back to my work. Okay, so as I just said, this exists some point, I called it C, such that the derivative at the point C is the slope of the line between the 2 points. So f of 4 minus f of 0 over 4 minus 0, okay? Which is 2 minus 0, 2 minus 0, 4 minus 0. Change in y over change in x, which is half. So there's some point where the derivative is half, okay? So what is f prime of c? It's just 1 over 2 root c. F prime of x is, so maybe even let's write that. F prime x is 1 over 2 root x. So we just evaluate at x is c. So 1 over 2 root c is half. We start solving for c. This half on this side and this half on this side would cancel. So 1 over root c is equal to 1, or c is equal to 1. Okay? So the point would be, that's the x coordinate. What's the y coordinate? We plug it in there. 1 square root 1, which is 1 comma 1. Okay? So the answer is B. Okay? This requires you to know what the mean value theorem says. Okay? This one, I believe, was done on the AB exam. Yes. So we just make the substitution. U is 1 plus x to help us out. Okay? So I won't do that again. This one also was in AB. Implicitly differentiate. That's the hint I'll give you here. Go look at the video for the worked out solution. Okay? For this one, the hint is this is a derivative. Okay? So I'll give you that as the hint. This one was in AB for what value? Oh, this one's in AB. This one also for what value of k will this guy have a relative max at x is -2? The hint here is, well, you see relative max, so you probably want to differentiate this guy. So differentiate x plus k over x. That's the hint. Okay. Number 8. I don't think this was on AB. Did I work it out? I did work it out. Okay. Let me get this. Okay. If h of x is f squared x, or this is better, f of x quantity squared minus g of x quantity squared. I really don't like this notation because people get confused. Okay, f prime of x is negative g of x, g prime of x is f of x, and h prime of x is equal to what? Okay, so let's just start by differentiating h. We would need chain rule. That's probably the key here. Okay, so h prime would be, we need to chain rule because remember I said this is f of x quantity squared. So we first do the power rule, it'll be 2 f of x to the first power times derivative of the inside, which is f derivative of f, which is f prime. Similarly, it'll be power rule minus 2 g of x to the first power times g prime of x by chain rule, okay? They give us f prime is negative g of x, so I plug that in. G prime is f of x, so I plug that in. So we see that we have a negative 2 fg and another negative 2 fg. So this is negative 4 fg. That's choice C. Okay. Area of the region bounded by the polar graph, r is square root 3 plus cosine theta, is given by the integral. Okay, so here you have to first remember that the area is half integral r squared d theta. Okay, this is the area of a sector. Okay, so we plug in, we can get the whole area from 0 to 2 pi. Hopefully you know that. This is half integral from 0 to 2 pi, 3 plus cosine theta d theta. Because the square root and the square root would cancel, so we're left with what's inside that. Okay? So, excuse me. I'm going to do one more thing where we know that instead of going from, well, this answer is correct, but we don't have it as one of the choices here. Okay? So we do one more step where we can actually go half the interval and then multiply the result by 2. Why can we do that? Well, we know that cosine, if from 0 to 2 pi, it eventually changes sign. Or maybe here's a better way to think of it actually. Okay, so let me actually rewrite it. So instead of from 0 to 2 pi, you could integrate from negative pi to pi. Okay, that's the same interval, right? And we know that since cosine's periodic, you can do this. You could shift this is one period of cosine, 0 to 2 pi, the period of cosine is 2 pi, right? This is just a constant, doesn't matter. So we can shift the period from negative pi to pi instead, okay? So when we have it like this, then it should be more recognizable that, well, once again, cosine is even, and this is technically also even. It's symmetric, so we can do half times 2 integral from 0 to pi of 3 plus cosine theta d theta, okay? Hopefully this is more intuitive. Instead of this step here, well, we can set up as negative pi to pi instead, and we can use that property that this is the even function, so we can, instead of going from negative pi to pi, we can go from 0 to pi and multiply the result by 2. Okay, so this is just integral from 0 to pi, 3 plus cosine theta d theta. Okay, which is the same thing I got there. Okay, so that is, which answer? That looks like D. Okay. Number 10, then we have this integral from 0 to 1, x squared divided by x squared plus 1 dx. Which technique of integration can we use here? There's probably multiple ways to solve it, and actually the answer key did it a totally different way than I did it. I solved it by remembering, I solved it on a different page also, let me find where I did it. I remember in the partial fraction decomposition portion, sometimes you have to do long division. Before you do partial fraction decomposition, if we have to do that, okay? The degrees are the same, so you can divide the polynomials, okay? So I did it over here. So we do long division this goes on the inside, the divisor, the bottom is on the outside. So this, once we do long division, how many times can x squared go into here? By once. So we do minus x squared plus 1. This is x squared plus 1 times 1. So that's minus x squared plus 1. Okay, minus quantity x squared plus 1. Okay, we subtract these two, we get negative 1. Okay, so the result of the long division is the quotient 1 plus the remainder, which is negative 1 over the divisor, which is x squared plus 1. Okay, so this is the result after long division, and this is very easy. This is just power rule, so that's x when we integrate. This is just arctan, so arctan x is here. Okay, evaluate from 0 to 1, so that's 1 minus arctan 1 minus 0 minus arctan 0. This is fundamental theorem calculus. Both these terms are 0. So we have 1 minus what's arctan of 1, that's pi over 4. And then we change the form to 4 minus pi over 4. So I just made it one fraction. We did that because that's the answer that they give us. 10 is A. Okay. You might be able to do a trig sub even. The solution key, if you were able to find it, it does a plus 1 and minus 1 on top and then splits it up, which also works if you were able to recognize that. Otherwise, long division works too, obviously, as you can see. Okay. This one was an optimization problem. We just use a distance formula, okay? See the AB video for the solution. This one, oh, this is super easy. Fundamental theorem calculus. If f of x is integral from 0 to x, e to minus t squared dt, the f prime of x is, where did I have this? This is over here. F prime, remember how to do this? You plug in the bound as the variable. That's as easy as that. So it'll be e to minus x squared, but then formally you have to do the chain rule. In this case, derivative of the bound, x is just 1, so it's just e to minus x squared. Okay, so I just wrote the whole step out here. That'll be e to the minus x squared. Okay, easy points. This one is a area problem. This is in the AB exam, so go look there. Basically, if I remember correctly, I set up two integrals, one from negative pi over 2 to k, and another one from k to pi over 2, and one of them is 3 times the area. You solve for k. Okay. This one, I believe I did it. Yes, it's a simple chain rule. dy du. Okay. If we're given these, so I wrote it again here. Okay. dy du by the chain rule is dy dx, dx du. Okay, remember you can kind of cancel this dx and this dx, so you get dy du again, okay? What's dy dx? That's just 2x. What's dx du? This is u in terms of x, so let's solve for x. That'll just be u plus 1 over 2 is equal to x. So we differentiate this with respect to u. That is just half, okay? So the answer is just x. Okay, moving on. This one I did on the AB, so I don't have an easy hint to give. It's a long explanation, if I remember correctly. This one that, again, is an AB. The hint here is, well, y prime is greater than 0. This should signal y is increasing. Y double prime less than 0. This should signal y is concave down. So if I remember correctly, it's this answer, B. 17, I also did on AB. Inflection point, once again, find y double prime. This is about derivative. This is in the AB exam also. At x is 3, the key here is absolute value. Remember how that looks? It looks like this. Okay, so the derivative does not exist at that turning point, sharp turn. So it should be non-existent, okay? These two were also on AB. This one, it asks when v attains max, so you want to differentiate v, so we want to find v prime. Equation for a tangent to the graph of this guy at the origin is you just find y prime to find the slope of the tangent line at x is 0, that's where the origin is, right? And then you have a point, you have a slope, find the equation. Okay, 21. This was also done on AB because it doesn't look like I worked it out here. This is about increasing, decreasing, relative maximum, so probably find f prime. Okay? And it's clearly not discontinuous anywhere because x squared is continuous everywhere, e is continuous everywhere, so it's for sure not c already. Okay? This one I did do. This is a new problem. Okay? If f of x is integral from 0 to x, this guy dt, which is following is false. So let's go one by one. Is f of 0 equal to 0? So f of 0, so you plug in 0 where there's x, integral from 0 to 0. Integral is area under the curve, right? No area, so it's equal to 0. That's true. So we can eliminate that. F is continuous at x for all x is greater than or equal to 0. Okay? This guy, the integrand itself, is continuous for t is, well, first of all, f, we're always starting from 0. Okay, so we care about when this curve, this 1 over square root t cubed minus 1, t cubed plus 2, I don't know where I read minus 1 from. This curve is, what was I just saying? I lost my train of thought. Okay, so we only care when, well, f is always starting from 0, so we only care when this function is greater than 0, okay? We don't care anything about less than 0. Okay, so is f continuous at x for all x is greater than or equal to 0? Well, this guy, the 1 over square root, I'm not going to write the whole thing, is continuous for t greater than or equal to 0, right? It's defined everywhere for t greater than or equal to 0. Since that's the case, then the area will exist. So f would be continuous, okay? So we eliminate that. Okay? F of 1 is greater than 0. Is that true or false? Is the area, area positive or up and above the x-axis? Or is it negative and below the x-axis, okay? We know this curve is positive. 1 over square root is greater than 0, okay? The square root is never negative, right? So area is positive, okay? So we know this is true. Okay? How about this one? F prime of 1 is 1 over root 3. What's f prime? This is fundamental theorem calculus again. We just did it not too long ago. So it's just 1 over square root of x cubed plus 2. Again, we just plug in the limits into the variable of integration, the silent variable of integration, which is t. So it becomes x cubed plus 2 times derivative of x, which is 1, okay? So evaluate at x is equal to 1. That is just 1 over root 3, okay? So this is true. And by process of elimination, this guy, okay? We can just go through it. Also, f of negative 1 is greater than 0. Well, even at negative 1, this guy would be positive, okay? So the integral from minus 1 to 0 would be, let's call that guy, or 1 over square root, is greater than 0. But this is f of negative 1. It's the integral from 0 to negative 1. Okay? So it would be negative, because the limits are flipped, right? So you can flip it back, but put a negative sign in front. So this is false. It has to be negative. Okay? Okay. This one, looks like I did probably do it. Okay. Yes, this has quite a lot of work actually. Okay, if the graph y is f of x contains the point 0, 2, dy dx is this guy, f of x is greater than 0 for all x, then f of x is equal to what? Okay? So, they give us this. We will need to solve this differential equation basically. So let's do separation of variables, so move all the y terms to one side, move all the x terms to the other side, okay? So we multiply this y here, so it becomes y dy. We move this dx over here, it'll be minus x over e to x squared dx. Okay, and then we integrate both sides. this right-hand side, we can do a little substitution. U is x squared. Du would be 2x dx, okay? So after we make the substitution, it would become negative half integral of du over e to the u, okay? We integrate both sides. Over here would be y squared over 2. Over this side would be plus half e to the negative u plus c, okay? We back substitute. Y squared over 2 is half e to the minus x squared plus c, okay? And we can multiply both sides by 2. Then we get y squared is e to the negative x squared plus c. Okay? They give us the initial condition of 0, 2, so let's plug that in. So y is 2, so 2 squared is e to the x is 0, so negative 0 squared plus c. 4 is equal to, e to 0 is 1, 1 plus c is equal to 3. So this would be your particular solution. That's the word I was looking for. Y squared is e to the negative x squared plus 3. Okay, we're asked for y or f, so y would be the square root, right? Technically, it's plus or minus the square root of this guy, but it says f is greater than 0, okay? So it'll just be the positive. So square root of e to the minus x squared plus 3. So let me write that down. Okay? So that's D. Okay. Next, this should have been done in AB. This is just implicit differentiation. That's the hint. Here was done in AB. You set up this integral and you solve it. You'll realize it's independent of n. This one, is this the AB problem? Yes, it was. Okay, so I remember it now. If you factor this, it'll be x minus 1 squared. So when you square root that, it's the absolute value of x minus 1. So you got to be careful for that. Okay. Again, check out the AB video for the worked out solution. This one was done in AB also. This one I would recommend for BC students. You just memorize what the integral of tangent is. It's this guy. Okay. If not, you could do a substitution, which you can look at. I don't remember if I actually did it in the AB video, but you can do a substitution after you change tangent back to sine over cosine. Okay. 28. What's this limit? Okay. If we plug in 0, it would be e to 0, which is 1. 1 minus 1 is 0 on the top. Tangent of 0 is 0 on the bottom. Okay, 0 over 0, indeterminate. So we got to do L'Hopital's rule here. Okay, so this is the original problem. We do L'Hopital's rule, so we differentiate at the top, we get 2e to 2x. Differentiate at the bottom, we get secant squared. Okay, now we plug in 0. We get 2 times 1 over 1, which is 2. Okay. This one, I wrote over here. Since I recognize it's something squared minus something squared, I was thinking trig sub. So if you see my crash course on trig sub video, I do it differently than what most people teach. I set up the triangle first, okay? I know that this is something squared minus something squared, so I know 2 is the hypotenuse, x is one of the sides, and square root of 4 minus x squared is the last side, okay? Now I want to substitute everything in this integrand in terms of theta using this triangle. Okay, I know that sine theta is x over 2. 2 sine theta is equal to x then. Okay, to find dx, we would need to differentiate 2 cosine theta, d theta is dx. Okay, and most people will just tell you to sub in here, but I'm telling you, you can save steps and do one more thing. Okay, we know that from this triangle, cosine theta is square root term over 2. So 2 cosine theta is square root of 4 minus x squared. Okay. We can substitute this whole guy, actually, in terms of theta. Okay? It doesn't look quite like it yet, because this is 4 minus x squared to the half over here. We need it to get it to the negative 3/2 power. So if we just exponentiate both sides to the negative 3 power, okay, then we get 1 over 8 cosine cubed on the bottom over here. And this one would just be this term over here. Okay, so this term would be this. So we substitute that here, and dx we found over here 2 cosine theta d theta. And then we also had to change the limits of integration because this is a definite integral. When x is 0, we plug into a definition here. 2 sine theta is 0, or sine theta is 0, which means theta is 0. Okay. How about when x is 1? Sine theta would be half. That's when theta is pi over 6. Okay, so this is our integral. And it's actually very easy to solve. We can simplify this 2, and 2 divided by 8 is 1/4. Okay, we can pull that out. Cosine divided by cosine cubed is cosine squared on the bottom. Okay, cosine squared on the bottom is the same thing as secant squared. Okay, the integral of secant squared, we know that. That's just tangent. Okay, so when we do fundamental theorem calculus, we get, when we plug in pi over 6, we get 1 over root 3. When we plug in 0, we get 0. Okay, so it's 1 over 4 root 3, and if we rationalize it, we'll get root 3 over 12. That is C. Excuse me. Okay. How many more problems are left? It's about 30 minutes now. Yeah, let me just call it a part here. I'll finish the rest of the problems in part 2.